Hello students, welcome back to JJ's physics class. Today we are going to discuss important questions and numerical from dual nature of radiation and matter. Let us start. Question number 1 is an electron and alpha particle have the same de Broglie wavelength associated with them. How are their kinetic energies related to each other? So we know that the maximum kinetic energy is given by this equation and de Broglie wavelength is given by lambda is equal to h by p. When you equate these two equations, you get it as the de Broglie wavelength as lambda is equal to h by root of 2m Then both the particles have same de Broglie wavelength. Therefore, you can equate de Broglie wavelength for alpha particle and de Broglie wavelength for electron. From this, you can say that mass of alpha particle is greater than that of mass of electron. Therefore, kinetic energy of electron is greater than that of kinetic energy of alpha particle. Question number 2. Two lines A and B in the plot given below show the variation of de Broglie wavelength lambda versus 1 by root B, where V is the acceleration potential for two particles carrying the same charge. Which one of these two represent particles of smaller mass? So the answer is, according to de Broglie wavelength, we have the equation. Then from this equation, you can say that the slope is given by 1 by root of m. Therefore, slope of B is greater than that of slope of A. So B represents particles of smaller mass. Question number 3. The figure shows a plot of three curves ABC showing the variation of photocurrent versus collector plate potential for three different intensities I1, I2 and I3, having frequencies nu1, nu2 and nu3 respectively incident on a photosensitive surface. Point out two curves for which the incident radiations have same frequency but different intensities. Curves A and B having same stopping potential but they have the different intensities. So curve A and B have same frequency but different intensities. Question number 4. The stopping potential in an experiment on photoelectric effect is 1.5 volt. What is the maximum kinetic energy of the photoelectrons emitted? So the answer is kinetic energy maximum is given by E into Vs. Then the stopping potential is given as 1.5. If you substitute in this equation 1.5 into electron volt, so you can convert electron volt to joule. So 1 electron volt is equal to 1.6 into 10 power of minus 19 joule. So you get it as 2.4 into 10 power of minus 19 joule. Question number 5. The maximum kinetic energy of photoelectron is 3 electron volt. What is its stopping potential? The answer is kinetic energy maximum is given by the same formula. You can write kinetic energy is maximum using this equation or this equation. So from this, stopping potential is given by kinetic energy maximum divided by E. 3 electron volt divided by E will give you 3 volt. Question number 6. Show graphically the variation of the de Broglie wavelength lambda with the potential V through which an electron is accelerated from rest. So this is the equation. We know that lambda is equal to h by root of 2 MeV. So lambda is proportional to 1 by root V. Therefore, the variation of V and lambda will be curve that is shown in this figure. So this is the nature of graph. Question number 7. Define the term stopping potential in relation to photoelectric effect. Answer is stopping potential is the minimum negative potential given to the anode in a photocell for which the photoelectric current becomes 0 and it is denoted by V suffix S. So it is independent of intensity of incident light. Question number 8. State de Broglie hypothesis. So de Broglie hypothesis states that matter has both particle nature and wave nature. So the wave nature of matter is understood from its wavelength called de Broglie wavelength given by lambda is equal to h by p, where p is the moment. Or another formula is p is equal to mv. If you substitute that, lambda is equal to h by mv, where h is a Planck's constant and m is mass of the particle and v is the velocity of the particle. Question number 9. A proton and an electron have same kinetic energy. Which one has greater de Broglie wavelength and why? Electron has a larger wavelength. The reason is de Broglie wavelength in terms of kinetic energy is given by lambda is equal to h by root of 2m ek, which is proportional to 1 by root m for the same kinetic energies. As an electron has a smaller mass than proton, an electron has a large de Broglie wavelength than a proton for the same kinetic energy. So electron has a large de Broglie wavelength. Question number 10. Calculate the kinetic energy of an electron having de Broglie wavelength of 1 angstrom. So the answer is lambda is 1 angstrom. You have to convert into meter. So 1 angstrom is nothing but 1 into 10 power of minus 10 meter. Then you can calculate the kinetic energy from de Broglie's equation. Lambda is equal to h by p, or k is equal to half mv square, or mv square is equal to 2k. So from that you get the equation p is equal to root of 2mk. Then equate the two equations, you get it as kinetic energy is equal to h square by lambda square into 1 by 2m. So we get the final equation as this. Then substitute all the values in this equation. You get the kinetic energy as 150 electron volt. Question number 11. Why is photoelectric emission not possible for all frequencies? The answer is photoelectric emission is possible only if the energy of the incident photon is greater than the work function of the material. Hence, the frequency nu of the incident radiation must be greater than the threshold frequency nu naught. Question number 12. The given graph shows the variation of photoelectric current versus applied voltage for two different photosensitive materials and for two different intensities of the incident radiation. Identify the pairs of curves that correspond to different materials but same intensity of incident radiation. So from this graph you can see that the similar materials will have same stopping potential and different materials will have different stopping potential, whatever may be the intensity. So the pair of the curves 1 and 3 correspond to different materials but having same intensity at this point, and the pair 2, 4 is different materials but they have the same intensity at this point. Question number 13. Write the expression for the de Broglie wavelength associated with a charged particle having charge q and mass m when it is accelerated by a potential v. So the expression is given by half mv square is equal to qv, or v is equal to this equation. Hence the de Broglie wavelength lambda is equal to h by p or h by mv. Substitute the value of v from this equation, then you get it as this as your final expression. Question number 14. Show on a plot the nature of variation of photoelectric current with the intensity of radiation incident on a photosensitive surface. So the graph shows photoelectric current versus the intensity of radiation. So you will get a straight line. Question number 15. Figure shows a plot of 1 by root b where v is the acceleration potential versus the de Broglie wavelength lambda in case of two particles having same charge q but different masses m1 and m2. Which line A or B represent a particle of larger mass? So here we have the equation. So separately write the formula for A, separately write the formula for B. When you equate these two equations, you can prove that mass of A will be less than that of mass of B. So B line represents larger mass because the slope is proportional to 1 by root m. Next, question number 16. Find the ratio of de Broglie wavelength associated with two electrons accelerated through 25 volt and 36 volt. So the answer is, we have the de Broglie wavelength of an electron lambda is equal to 12.27 divided by root b. So for lambda 1 and lambda 2 you get this expression. So when you equate these two equations you get it as lambda 1 by lambda 2 will be what? 6 by 5. Question number 17. Define intensity of radiation on the basis of photon picture of light. Write its SI unit. So intensity is nothing but the amount of light energy or photon energy incident per meter square per second. SI unit of intensity is watt per meter square or joule per second meter square.